Welcome to Math with Professor V. Here's your latest integral of the day. We have a definite integral from 0 to 1 over rad 3 of 1 over t squared plus 1 to the 7 halves dt. So hopefully it's pretty clear that when you start off, you're going to need to do trig sub. And notice this is a definite integral, so we're going to change our limits of integration as well. I just made a video showing how to change limits of integration for trig sub and really breaking it down and comparing it to why that's different with the technique or the process basically when we change limits of integration for u sub. So if you're struggling with this, which a lot of students are, then check out that video. I've linked it in the description. But otherwise, I'm going to just jump right in. So which trig sub is appropriate? We have 3 to pick from. Please don't start making up your own. When you have a variable squared plus a constant, then it's time to use tangent, right? So we let t equal a tan theta, and a here is equal to 1. So I'm just going to let t equal 1 tangent theta. And then we'll differentiate both sides. So dt is secant squared theta d theta. And then now we have to change our limits of integration. So these limits, 0 and 1 over rad 3, belong to the variable t. So I'm going to substitute them in for t and solve for theta. So 0 equals tan theta, and 1 over rad 3 equals tan theta. So let's think, when is tangent 0? When theta is 0. And when is tangent 1 over rad 3? So that means sine was 1/2 and cosine was rad 3 over 2. That's at pi over 6. Hooray. So now let's rewrite our integral all in terms of theta. We're going to go from 0 to pi over 6. dt in the numerator is secant squared theta d theta. And then in the denominator, we have t squared plus 1. So that's tan squared theta plus 1 to the 7 halves. Beautiful. So remember, we just did trig sub, so we can use a Pythagorean identity to simplify. So tan squared theta plus 1, that's secant squared theta. Secant squared theta raised to the 7 halves. Let me write it this way. It's secant theta squared raised to the 7 halves. Do you remember your laws of exponents? When you raise a power to another power, you multiply. You multiply these exponents. So 2 times 7 halves, the 2 will cancel, right? And I just end up with secant theta raised to the 7th. Okay, so here we're going to have integral 0 to pi over 6 secant squared theta d theta over secant theta to the 7th. Usually we put the 7 inside as a little abbreviation, but when taking derivatives or playing around with things, if you want to write the exponent outside of some parentheses, I recommend it. It'll be helpful, especially if you get confused with this stuff. Okay, now we can simplify, right? Because I can cancel out secant squared here, and then now I'm only going to have secant to the 5th theta in the denominator. So 1 over secant to the 5th theta, d theta. And I'm like, why would I have 1 over secant to the 5th? That's not helpful. That's cosine to the 5th. Let's rewrite it. Cosine to the 5th theta d theta. Okay, how are we doing up to here? Are you guys good? Now, I love it. When I have an odd power on cosine or sine, we just pull one factor out and we're going to do a u sub. Okay, so you should have learned this technique before trig sub, but in case you forgot, let me remind you. So you take one factor out. So I'm going to have cosine to the 4th theta times cosine theta d theta. Yes? The point of doing this is I want all of this to be absorbed or to basically be my du. So then you think backwards. If du is cosine theta d theta, then who would u have to be? Very good. U would need to be sine theta. And then you take a peek over here and you go, uh-oh, I don't have sine theta. But that's totally fine because I have an even power of cosine. So I'm just going to rewrite it. Because cosine to the 4th theta is cosine squared theta squared, right? And then I can rewrite cosine squared theta as 1 minus sine squared theta squared. And then just leave that cosine theta d theta out there. Integral 0 to pi over 6. You see how that worked out so beautifully? And it doesn't work out as beautifully when the power is even, unfortunately. You can't pluck off an odd one and do this substitution. So we have to do something else, which is more painful. Okay, so here we go. If u is sine theta, then yes, du will be cosine theta d theta. Perfect, which I have right there. So then we're going to have integral 1 minus u squared squared du. And you know what we need to do immediately. Yes, do not delay. We're going to change these limits of integration. Currently, these limits belong to which variable? Look at the integral. They're limits for theta. I need new limits for u. So I'm going to plug in 0 pi over 6 for theta and get my new limits for u. So u of 0 is sine of 0, which is 0. And then u of pi over 6, that's sine of pi over 6. What's that? 1/2. Very good. Okay, so my new limits go from 0 to 1/2. Yay, we're almost there. The end is in sight, I hope. We can just multiply everything out now and then anti-differentiate term by term. So we're going to have 0 to 1/2, 1 minus 2u squared plus u to the 4th du. And then now, oh, this is relaxing. Just go term by term, take your antiderivatives. This will be u minus 2/3 u cubed plus 1/5 u to the 5th. We'll evaluate it from 0 to 1/2. Okay, we have 1/2 minus 2/3 times 1/2 cubed, that's 1/8, plus 1/5 times 1/2 to the 5th would be 1 over 32 minus 0 for the lower limit. Okay, what's my common denominator? Let me see. This is 3, this is 2 cubed, this is 2 to the 5th. It needs a 3. So 5 times 3 times 32, I believe that's 480. Let me double check. 5 times 3 times 32. Yes, so my LCD is 480. So let's get there. So this is 1/2 minus 2 over 24 plus 1 over 160. This needs 3, top and bottom. This needs 20, top and bottom. And this needs 240, top and bottom. So we're going to have 240 minus 40 plus 3 over 480. 240 minus 40 plus 3, 203 over 480. And that doesn't reduce. So there's our final answer. Voila. It was so lovely until the end with that ugly fraction, but oh well. You know, we can't discriminate. Poor thing is a number. Did I miss the 0? My apologies. I really liked this integral. I don't know. I liked the trig sub. I liked the u sub. I liked it all. So I hope you liked it just as much. I have fun digging up these problems. Anyways, give the video a thumbs up, subscribe if you haven't already. If you solved it differently, I'm so curious to hear how. So let me know what you did in the comments down below, or if you did the same thing as me. Also, yes, I ditched the new mic. Nobody liked it, and they were like, we missed the tapping, we missed the old mic, so it's back. I thought I would upgrade and get some new stuff, but if it doesn't go over well, then I don't need to do things like that. You guys let me know. Also, if you need to review any of the integration techniques that I used in this video, then hop right over to the Calculus 2 video lectures playlist. And I also have some key videos linked in the description to help you guys out. You can also follow me on Instagram, TikTok, Twitter, Math with Professor V. Thank you guys so much for your support. I love you all, and I'll be back sooner than later. Bye.